I've never used microphone before, so. So the problem is here, we have socio-demographic characteristics of the individuals as the input to the model. And then this model is going to give us, identify what activities our people are planning to do and what's going to be their duration. Then given the location of the different activities, even in some of the models now we are developing, we are trying to identify the location of the activities also. And I mean, we are trying to infer it. The objective is how people schedule these activities during different times of the day, such that this is the kind of the pattern trajectory of the movement of the people in the day. So if you look at our own life, this problem is already a complex problem. Looking at the beginning of the day, we decide to do some activities, but by the end of the day, due to some uncertainties happening, so the behavior changes. The framework we are using, first we take activity diary data, then we segment patterns of the behaviors, patterns of the peoples. By pattern, I mean that the trajectory that we showed before. In the population, we try to cluster these patterns to some homogeneous sets. Then inside each set, we use different techniques to infer the list of the activities in the agenda of the day, which these techniques are going to be ensemble of multivariate probit model, it's the econometric model, support vector machines applied on micro models, hidden Markov models, and adaptive boosting algorithm. Then from there, the next step, after we identify what's going to be the scheduling list of the activities, we will schedule these activities in the people's daily patterns based on two techniques. One is going to be rule-based model, and the other is constraint optimization model. This part gives us a development of the model that we are trying to develop, and then, given the supply side, which is network, and regional socio-demographics, the regional activity pattern of the people are going to be used, which this part can be used for policy and decision analysis and decisions in the policy systems and planning. So the data we used here was traditional household travel survey data for 2000-2001. We categorized activities of the people based on a type of activities to 5 groups, home, work, school, maintenance, personal, socializing, pick-up, drop-off, and other activities. The population size at the end, clean data after processing, was 26,000 patterns of the people. Pattern segmentation, which is the first step, starts with clustering patterns using different techniques, using different distance measures. One measure is sequence alignment, which is based on assuming that we use a resemblance as the patterns of the human being look like chromosomes of the genes. Then try to understand what are the difference between these patterns are. And the other is agenda similarity. We use a weighted combination of them, the clusters of patterns. But however, how these patterns are going to be weighted in the next stage, we are using some complex modeling techniques to understand what's going to be the W1 and W2. The results of these models are going to give us the inference based on the clusters IDs and based on the demographics of the people falling inside each cluster. We identify that what's the dependency of the people, how people with different household characteristics or individual characteristics fall in these groups, and having this information, what kind of predictions we can make. Let's start with clustering patterns. I will bring a short example. Here we have, suppose we have 3 individuals. What we do, from 5 a.m. to 23 in the afternoon, we discretize the patterns of the people to different type of activities they have been doing. For example, this person have been at home for 4 hours, then goes to the work and then comes back to home. The second person goes to school in midday, and the last one goes to work. The reason we are discretizing it because we want to know that take into account on the duration of the activities and also to the start time and end time of the activities, and we are clustering the patterns. If we use sequence alignment, I'm not going to go into detail to the sequence alignment, but I can answer any questions later on if you're interested. The difference, the number of steps that I need to displace these 2 patterns to be similar, for these 3 sets of activities is given computed like this, which is, for example, between 1 and 2. If you just replace 8 of these patterns together, they're going to be exactly similar patterns. So the distance between these patterns are measured as sequence alignment. The second technique is agenda dissimilarity. identifying that, for example, activity 1, the person, individual 1, has only one out-of-home activity, which is work, and second has a school. So the similarity between these two patterns is way higher than the similarity between individual 1 and 3, which both of them have work activity. So we use the weighted combination of them. So we use this measure. So this is going to be the dissimilarity matrix for entire 26,000 people which we had in the data set to identify that how dissimilar these patterns are. So the next step, the techniques that we use, so for each of these set of weights, we use the combination of affinity propagation and k-means clustering. Affinity propagation is a message passing algorithm to cluster different patterns in computer science. The benefits of the affinity propagation is that the number of clusters is not given. It comes out of the data set. It's the nature of the data. And also a pretty fast algorithm. So based on different sets of weights, for example, in the range of 0 to 1, we will have different sets of clusters. Inside each cluster, we have sets of patterns of 26,000 people. So now the question is that which one of these clusters gives us the best set of patterns, which goes to the next step of this algorithm. How we identify it. I'm not going to go into details, just showing the algorithm. We select some n people from the sample. We set the data, then find which cluster people belong to. Then from here, we assign individuals to clusters and infer time windows. Then this model goes to a very complex activity-based model to identify that what is the patterns of the people, estimated pattern. On the other side, in the data set, we have the observed pattern. Comparing these two is going to give us the error term. So the next increment, we increase theta, we go to the next set of weights. This set of weights is going to give us a new set of clusters. In the set of clusters, again, we identify what's going to be time windows, estimate the error. Finally, after we enumerated all the combination of the weights, the pattern which gives us the minimum error, the combination of the W's which gives us the minimum error is going to be the best set of the errors. So let's see how does it look like. The best set for our data set looks like this. The best combination of the weights gives us these 8 clusters. What does it mean? It means that we clustered 26,000 of the patterns and we were able to capture them by only 8 clusters. Here, this x-axis shows the cluster IDs and the vertical axis shows the time of the day, means that what people have been doing at different times of the day, and we have different sets of activities. These colors shows the different sets of activities. And on the top, we have the number of people falling inside each groups. So what are the application of this technique is? Let's go to the next part, which is going to be inference. I will explain this in details in the next slide. As we know, inside each cluster, we have some socio-demographics of the people, and we know their patterns. Now the question is that to know, for example, a household who have a kid under the age of 2, what cluster they might belong, or a student who goes to school, what cluster they might belong, what's their most representative pattern, activity patterns. Here, in order to do this inference, we use decision trees to identify how people belong to different clusters. For example, the important parameters, the important factors shows itself in this graph. Like one of the factors is if people are going to school or not, if they're working from home or not. For example, the first stage here, one of the classes is saying that if the person goes to school and younger than 18 years old, the most likely 72% of the people in this cluster are those people who go to the cluster 7. So in this case, we can identify that which cluster people might belong based on their pattern and based on their demographics. So the second application, which was quite interesting, and we are working on it right now to compare different cities in these states, is can we use this representative pattern to generate the temporal share of different activities during the day? These graphs, the first graph, we just take 8 representative pattern and just multiply them by the number of the population inside each of them. This graph shows that in the horizontal axis shows the time of day, vertical axis shows the percent or share of different activities here. For example, as you see here, the big component is here is home activities and the others are like work activities, school activities. The second graph, we take the same clusters, 8 representative patterns, just perturb the arrival time to different activities based on the arrival time distribution inside each clusters. Now let's see, compare them to the observed data. And here's the observed pattern. If we look at here using these clustering techniques, we can, over 90%, we can predict what the temporal share of different activities during the day are, which is quite interesting. Now, what we are proposing now, we are working now, is that compare the temporal share of patterns to see how the clusters in different cities change. Here we are looking at the California, and the components that we are looking are the demographics of the people. But what if we look at the components of different cities with different networks or different ethnicity, diversity of the people living there, even climate, the weather. Like I live in New York right now, the weather impacts people's time use and behavior rather than California, which is sunny always and people go out and have more recreational activities. So this is a large proposal that we are writing right now to see that how does it impact living different cities, city infrastructure, subway system, network connectivity, graph models of the network, and also like here in California, we have more Hispanic people. In New York, we have more African-American people. Diversity is more than, or Asian people in California are more. So it's to see that how these components impacts people's time use and behavior if we can have a larger scale and compare them. So the next stage was inferring list of activities in the agenda. As we talked, we use multivariate probability model and components of the models. Let's talk about them. So here the models, we use socio-demographic characteristics of the individuals, and use 3 modules. The output of the model is going to tell us either the person, it's going to be binary response model, either the person is going to go to work activity or not, or to school activity or not. So because the first step, we understand that which clusters people belong to. In the second step, we want to know that inside each cluster, what makes people to make selections in terms of activities they're planning to perform. One of the models is multivariate probability, the socio-demographic variables that we use are in both in individual level and household level, like age, gender, driving, license, and all the information which are available in household travel survey data. So multivariate probability model is the response one, econometrics model, response models. One indicates if the person has participated in the activity, 0 is not, these are from data. We assume that they are correlated with some normal distribution, which is Z, which is a factor of demographics of the people with some variables plus random error term, which identifies the correlation between the participation in different activities. So if this is normal distribution, then gamma is going to have this full complete correlation matrix. Now we need to identify the correlation matrix in the components of the off-diagonal term, plus the beta values, which is quite, this is not very straightforward techniques, and especially we cannot solve it analytically. So I borrowed techniques from Gibbs sampling and Markov chain Monte Carlo techniques. So we used Gibbs sampling techniques. The techniques that I use especially is parameter expanded reparameterization and the metropolis Hastings algorithm. I'm not going to go to the math, just talk about the steps, and again, we can talk later if you're interested. The step starts with initialization. We sample covariate beta from a normal distribution with the mean of 0 and with the variance of the 1 and the mean, with the mean and variance from OLS estimation, we grab them. Then we estimate latent variable of the Z. Then from there, we sample correlation matrix from inverse Richard distribution. And finally, we accept correlation matrix through metropolis algorithm, which is generated from some random number if it is greater than some threshold. So we accept it, or otherwise we reject it. The second module we use is the structure of hidden Markov model, which is Markov chain with conditional random field. The reason is conditional random field because we assume that, let's suppose these boxes, each of these boxes shows that the type of activities I'm doing at different states of the day. State of the day means that, for example, if I'm participating in 2 activities, I will have 2 states in a day. If I'm participating in 10 activities, I will have 10 states during the day. We assume that any decision I make to participate in one activity in any stage of the day depends on my previous activities during that day. And also it depends who I am. For example, if I have some household or parenting roles, my role is going to be different if I'm a single. Or everything, the components are changing. So we have a pretty complex model, means that participation in this state depends on my previous states plus my social demographics. The second is that we assume that we have full connected network or full connected correlation between these states. Estimation techniques, we borrow from data mining techniques, support vector machines. What support vector machines do, it's the supervised classifying techniques. Suppose we have 2 classes. These classes indicate that if I participate in this activity, class 1 or class 2, these are different classes identified. If you look at here, if you want to classify these points, classification with a single line is impossible here. perfect classification, because they are so, we need to have these nonlinear functions. So what we do using support vector machine, we can take these parameters to a higher level. If you take them to a higher level with kernel function, then these points which are inseparable in a 2 space can become separable in a higher level space. So the idea is that finding this hyperplane such that it maximizes the risk of misclassification. The risk of misclassification is being maximized is that the hyperplane is such that we have the highest margin between different classes. So that was the idea. We use the support vector machine as a second module to identify that what are the activities that people are performing or participating at each stage of the day. So the first one was multivariate probit model. The second one is support vector machine. And the last one, which I'm going to talk right now, is adaptive boosting algorithm. Let's bring an example. Adaptive boosting algorithm is a combination of different classifiers. It uses different, for example, here, we want to identify some classifiers which we can classify these plus and minus points as perfectly as possible. So what it does, first it uses the first classifier. So we identify these ones are plus, these ones are minus. But if you look at here, we have these points to be classified mistakenly. So what we do in the next stage, it gives them higher weight for the points which are misclassified. So it uses a new classifier here. So again, here we have these points to be classified mistakenly. So we use another technique, we give them higher weight. So at the end, the combination of these classifiers gives us the perfect classification for the points we have. So in a mathematical formulation, we can look at this way. For every data point n, depending on the classifier, and y's are classifiers, we have different weights based on their previous classification errors. So the combination of these classifiers at the end shows that if y is positive or negative. Positive means that y belongs to a set or you participate in one activity. Negative means that you don't participate in an activity. So this was the last module that we used to identify that what goes to the agenda of the people, what people decide to do during the day. We are not talking about scheduling. Like the scheduling is going to come second stage. So far we understand that given the social demographics of the people, what they might likely participate in the activities. So last step is activity scheduling. I use two techniques. One is rule-based models, which is based on logical thinking of the human being. And the second one is the mixed integer programming framework, which gives us a lot of flexibility in terms of network modeling, because that's a network-based model. So for rule-based model, for both of these techniques, actually, we go inside each cluster, which we had identified from the beginning, and try to identify for each of these types of activities, the arrival time to activities, and activity duration based on demographics of the people. Like the person who is going to work probably is a very early morning person who's employed in the company, and these are the characteristics goes into it. So how this scheduling works on, for the scheduling, we take demographics of the people, identify the cluster number that people belong to using the decision trees I identified before. Therefore, each cluster, we identify activity duration, arrival time, and out-of-home time spent using adaptive boosting algorithm. From there, after we identify that, we insert top priority activity and update set of activities. Then we see that if the sum of the duration of the people have spent out of home is less than budget that people want to spend out of home or not. If it is, the activity is being added to the schedule, otherwise it's not. So let's see what's going to be the result. So far we've talked about all these techniques and we don't know what's going to be the result look like. Here's the estimation. This one shows that edit distance between observed and patterns in minutes. And this is the error. The average error is 213 minutes. It might seem big, but if you look at our own human being life, at the beginning we decide to do a lot of things, at the end of the day we don't do them. So actually looking at this way, it's a quite good achievement using all these techniques and all these only 26,000 data that we had. Suppose now mobile data, GPS data gives us multi-day data. Suppose we had like patterns of the people for months, so we can understand what are the needs of the people. So instead of estimating agenda based on one day's activity, we might be able to estimate what goes to schedule of the people during different times of the day. And also routines of the behavior of the people. A person who wakes up at 8 a.m. normally wakes up at 8 a.m. for the most of the time. So we can learn these routines. Like looking at the fact that we had only multi-day data, one-day data, and we had 26,000 individuals, this result is quite significant. So the next type of the model that I use for scheduling is household activity pattern problem developed by Dr. Recker. So this model is a mixed integer optimization model, a variation of pickup and delivery problem. It's a quite complex model. It's a network-based model. The objective function is minimizes the distility of the activities, which goes travel costs, off-home time spent, waiting time before home, and late arrival to activity. The constraint sets are vehicle routing constraints, means that every node should be visited by one vehicle, and then if someone goes to one node, then the person should leave that node, and all the connectivities. I didn't bring the equation because I didn't want to make them so complex. The model is so complex model. And then time windows constraint means that for every activity to be visited, it should be at some significant time windows. For example, you cannot go to grocery shopping at 2 a.m. In most places, there's no grocery shopping working. In New York, the stores are open all the time, but not in all the cities you have. And then, what happened? Okay. And decision variables, the output of this model, which is going to be the decision variables we are intending to find, shows us what is the order of the visits, how people is scheduled, and how people visit these activities. We made some changes to the objective function of the hub based on the results that we had from clustering techniques. Now we are working on that, and we are trying to see that how does it work. But some of it we have the result, but some of it we are trying to identify what are the weights of these different parameters. First, we assume that people who belong to the same cluster, they tend to behave the same. So we are trying to say that, okay, we want to minimize the deviation from arrival time to activities for the people from the cluster mean, or deviation from the time budget and out-of-home time spent budget. And then what's going to be the results look like? Again, the scheduling using the hub, we took the same steps. We use the clusters, identify people to the cluster based on their demographics. Then we infer time of activities, duration, and everything. Then from here, we solve the hub, and the results looks like this. In this stage, the error term is higher. However, we always claim that this model is better because it's network-based model. In this model, we can identify, we can add modal components here. And also, these results that we got here, it was before calibrating the weights of the different multi-objective function. Now, the preliminary results of the study shows that we can improve the model, and we improve this accuracy of the model. So, in conclusion, we developed a comprehensive framework to understand activity scheduling behavior of the people. The key advantages of the model is that the only data we used was network data and also demographics of the people. We inferred activity agenda model as part of the model. If you look at most of the travel activity-based models, in most of these studies, they say that we know that mandatory activities our people are going to do. Or most of them, they have some assumptions about the type of activities go to the agenda. But this inference was as part of this complex model that we are proposing here. Inferring limited set of representative patterns as a core activities, like we were able to use 8 representative patterns as a kind of cluster set, representative pattern of the people, and we were able to capture temporal share of different activities for over 90% of the time, which was quite interesting results. And then we could capture the dependency between demographics, variables, and activity patterns, which all of these models were functional demographics of the people. And also, we could bring the travel behavior and components of the supply side by using household activity pattern problem, because HAP is a pickup and delivery problem. It's a network-based model, so being able to incorporate it in the modeling helps us to be able to see the network base. And finally, this model has a potential to incorporate modal components, and at the end, the entire things that we talk right now, we were able to develop a package, MATLAB-based package. Entire thing can be easily done inside it. And the user or agencies, we are planning to send it to the agencies can just use the Excel data or for the input data, and that's it. From there, all the techniques are going to be done with the tutorial, of course, attached to the model. So it's another idea. So the current projects and future works that now we are working, one of the works we have done is mining activity pattern trajectories using passive data. Using these techniques, partial this data, and also network-based, we were able to allocate patterns in the different parts of the network. The second, now we are working in New York, is that like assessing influence of urban forms and patterns of human activity and travel, like to see that how city development, how infrastructure of the city impacts the representative patterns of each city. We try to cluster activity patterns in different regions and try to understand the association between the different parameters and the patterns that people are behaving. Another research that we are working with Hunter College people there is like detecting drivers' reaction to environmental awareness. There's a project, EnviroCar project in Germany. Now we are doing the pilot test in New York to understand that how people, if they know that how much pollutants they're creating or emitting their vehicles, how it's going to impact their travel behavior. We are working on providing customized itineraries to travel. To see that with the different proposals, the objective function is going to be like reducing obesity or risks of being exposed to environmental pollutants. And finally, the project that we are working is resource allocation and service scheduling under extreme rainfall events to see that if the components of the model is going to be used is the fact that using this model, we can understand spatial temporal distribution of different parts of the regions of this network. If we know this, if we know that how people are distributed, and we know that what are the likelihood of different events happening, what information, this information, how it can be used to identify the resources and to understand, to allocate resources in different segments of the networks. And by this, I'm finishing my presentation. Thank you. If you have questions, I would be happy to answer. Thank you.
I have a question.
Sure.
So when I look at the patterns you identify, and maybe I misunderstood, so you can tell me if I did.
Sure.
I don't. Do I have to use this? Yes. I could not see that you're using some kind of pegs around which activities are organized. One of the advantages of everyday behavior of people is that there are some locations that are fixed in place. Home, for most people, work, and schools are the three major anchors. And also there is some fixity in time. Children that go to school have to appear at school at a specific time. Otherwise, parents are in trouble, and they have to be picked up at a specific time. So we can take these pegs in time and space and use them to infer patterns around these pegs, and makes it much easier.
Exactly.
So are you doing this, or?
No, the fact that that's actually one of the studies most of the time they do, like, for example, they try to understand other activities of the people around work activity. For example, one example, like Dr. Bahat does all the time, workers activity, non-workers activity, and then identify that these are work activities. So before, prior, then after that, they try to understand what are the flexible activities are being distributed. Actually, this is one of the we thought that this should show itself in the data. That's the reason we try to identify even one of the factors they're talking in the conclusion, that we are trying to infer even the agenda, because for a person in the test set, we don't know if the person is going to go to work in that day or not. We don't know if the person is working. We don't know their work location. The objective of this model is that we have 15, okay, I forgot to tell that the final data, final levels of the estimation, the accuracy, was 15% of the people which were not used in the training of the model. We used 85% of the model to train entire thing, then 15%. So in reality, we don't have such, if you want to have like estimation of the prediction of the people's behavior, this information is not that much granted or that much given for us. So we try to see that if we can infer them there. Of course, if we had used them, the agenda estimation, we could skip that part or reduce it to only non-mandatory activities, because those activities which you are talking about are school and work activities which are mandatory. So if we focus to only non-mandatory activities, we are actually eliminating 2 of those type of activities. So our correlation matrix even becomes smaller, and the parameters we need to estimate it becomes less. So the estimation is going to be very accuracy. That's why I'm telling this 200 minutes compared to the fact that we have no idea, no assumptions about what people are going to do. The only thing we know is who they are, and if their job is flexible or not, if their job location is flexible or not. We have this information about the job, or if they're employed or not. We have this information. Exactly. Yeah, we know where they live. Exactly. We know where they live. But from there, we try to see that how they are distributed. But in this part, we are talking about what they are going to do. In the next part, which we just submitted the paper, and fortunately it was accepted, was trying to allocate the people at different parts of the network. Now to see that if I live here, how far away from home I normally travel, and which of these places is going to have the attraction for my trip. Yeah. Thank you. Sure. I cannot see. Can I just turn on the lights? Yeah.
I have a kind of a question that arises when associated with a study that I did a few years back on evacuation of an area. And we have several neighborhoods in Santa Barbara that are at considerable risk for wildfire, and there have been some events where these neighborhoods have been overwhelmed by fire, and there's been almost immediate evacuation. Now, one of the issues is that in simulating these events using microscale simulation models, we had to make a lot of assumptions. And these assumptions were associated with how many people were in the neighborhood and so forth, of which you could easily address with a good behavior-based model like the modeling that you're doing. But what we found once we put a few graduate students at various intersections and monitored the traffic that was going in and out. And what we found was, in this one neighborhood, for almost every person that left, probably to take a person to a child to school or somebody to work and so forth, we saw another vehicle enter. It could be a gardener, it could be a package delivery, it could be a contractor. This is a relatively upscale neighborhood, but what we found was the population, we kind of estimated the population within the neighborhood really didn't change. So what I'm really asking here is that what are you doing to address this other issue about all of these service vehicles, whether they're UPS or whatever, that they're plying the roads at the same time that these people are making these trips, and there's a tremendous number of these trips that are entering neighborhoods and so forth that are exerting traffic demand as well.
Yeah, for that case, we looked at people's like. Your question is about evacuation or just normal, like? In this study, we didn't look at that way because that one goes as a kind of, we can look at it as a kind of cargo because traveling like UPS systems are going from one place to another. We are looking at the personal trips of the people. However, another interesting thing would be, for most of the evacuation studies, what people are doing, they look at the residential location of the people and try to understand how important is the places. But if we look at the broader perspective, the important thing is the spatial temporal distribution of the people in the network, which is should be taken into account. With our model, we can look at that way, like to see that what are different zones of the city have different potential for attraction of the trips and what people are doing. And also eliminating mandatory activities and non-mandatory activities because, for example, when the evacuation things happen, most of the time can switch or reschedule their non-mandatory activities. So let's focus on the mandatory activities and see that what's kind of special temporal distribution of the patterns in the city are. But in case your question for the trips are visiting different nodes or not, no, we didn't look at that case. We didn't look at that micro-simulation level for the different trucks or different UPS system that go into system or not. No, unfortunately, we don't have it in this model. But definitely, it's impacting the traffic also on the roads.
Just a little bit of a follow-up.
Sure.
I recognize that the travel survey data only contains certain people.
Yeah.
But if you're going to work with an event like a rainfall event, one of your last objectives that you had mentioned, it seems to me that you need to know a lot more about the business side.
That's actually what we are doing.
Of the traffic.
Yeah, that's what we are doing over there now. What we will do, we will use these 8 clusters that we had and use the land use pattern to understand how it's going to incorporate entire population. So one of the works that we are doing, if we can incorporate what is like millions of people are going to behave based on these 30,000 patterns that we have, to see that if we can allocate them the network, from there we can have some distribution of the people in the network. Yeah, definitely. The travel survey data, all the time we write in the papers and we read in the papers that they're rich data, but they're one-day data. That's the one downside. And the other thing is it's only a selective number of the people. So now that I'm working, I'm trying to see that if I can use data fusion techniques to understand if we can take the 30,000 patterns to a higher level. But of course, the land use models comes there. If we want to use this data for resource allocation, we're using land use models to see that where people are going to go and find this distribution also. Yeah. Thank you.
Yeah. Thank you, yeah, in the interest of time, so we go to the next speaker, and then we will have the chance to answer more questions.
Thank you.
All right.
Thank you.
Thanks again.
Thank you so much.